In this video, we will cover two flip-flops. The first one is D flip-flop and the second one is T flip-flop. In D flip-flop, we have one input D and two outputs Q and Q prime. Here, if we provide 0 as input, we get an output of 0. This 0 is then stored inside the flip-flop. Again, if we provide 1 in the input D, we get Q equal to 1. This 1 is then stored inside the flip-flop. Now let's analyze the circuit diagram of D flip-flop. Here, we use a clock pulse as an input. The flip-flop works only when the clock pulse is equal to 1. We can see that D flip-flop is extremely similar to SR flip-flop. There are slight differences in the first part of the circuit area where the inputs are included. So if we just make a slight modification in the input part of the set reset flip-flop, we can create a D flip-flop. Now, if we set the clock as 1 and D equal to 0, then firstly, we will get 1 and 0 from the NAND gates. So one of the inputs for the first NOR gate will become 1. In NOR gate, if any of the inputs become 1, then the output is automatically 0. So in this case, the output of the first NOR gate will become 0. So we get Q equal to 0. This value of Q will work as an input to the second NOR gate. So for this gate, we get 0 NOR 0, which is 1. So the value of Q prime equals to 1. So we can see that if we set D equal to 0, then Q becomes 0 and Q prime becomes 1. Next, if we set D equal to 1 and clock equal to 1, then firstly, we will get 0 and 1 from the NAND gates. Since one input for the second NOR gate is 1, therefore, we will get Q prime equal to 0. This value of Q prime will work as an input for the first NOR gate. Therefore, we will get 0 NOR 0, which results in 1. So the value of Q will be 1. So for the input D equal to 1, we have Q equal to 1 and Q prime equal to 0. Now let's construct the characteristics table from the circuit diagram. In the characteristics table, we can see that whenever D equals to 0, next state Qt plus 1 is also 0. Whenever D equals to 1, the next state Qt plus 1 is also 1. Here our present state Qt is being completely ignored. So we can say that the output equation for D flip-flop is Qt plus 1 equal to D. Next, we will see T flip-flop. T flip-flop mainly has two operations, no change and toggle. Just like D flip-flop, in T flip-flop, we have one input T and two outputs Q and Q prime. Here we can see that T flip-flop's circuit diagram is extremely similar to JK flip-flop's circuit diagram. The only difference is that we are providing T in J and K both value. So if we provide the same input in J and K, we can construct T flip-flop using JK flip-flop. Now let's analyze the characteristics table for T flip-flop. Whenever T equals to 0, we have no change operation. So if the present state Qt equals to 0, then Qt plus 1 will also be 0. Again, if Qt is equal to 1, then Qt plus 1 will be also 1. Whenever T is equal to 1, we have toggle operation. So if the present state Qt is 1, then the output or the next state will be 0. And whenever the present state Qt equals to 0, the next state Qt plus 1 will be 1. So if we want the output equation for T flip-flop, firstly we will need the truth table. In the truth table, Qt and T will be our input and Qt plus 1 will be our output. In the first combination, t equals to 0, which means this is a no change operation. So the value of qt will be the value of qt plus 1, which is 0. In the next combination, the value of t is 1, which is a toggle operation. So the value of qt is 0, hence qt plus 1 will be 1. In the next combination, since t equals to 0, this is a no change operation. So qt and qt plus 1 will be same. In the final combination, t equals to 1, which is a toggle operation. So since qt is equal to 1, qt plus 1 will be 0. So from the truth table, if we use Boolean expression, we get our final equation for the output, which is qt plus 1 equals to qt prime t plus qt t prime. So in this video, we have seen the characteristics table, circuit diagram, and the output equation for T and D flip-flop. In the next video, we will see the excitation table for the flip-flops.